Okay, so we'll do a couple of trigonometric identities, and the idea is that you need to convert both sides of these identities, of this equation, to something that looks equal. And the things that are available to you are all of the equations that we know so far. Sine, well, I'll show you a chart of them. Here in the book, we can see that we have the Pythagorean identities. Sine squared plus cosine squared equals 1. Tangent is sine over cosine. Cosecant is 1 over sine. Secant is 1 over cosine. Cotangent is 1 over sine. We also have the compound angle formulas. These are the ones that are available to us to use in order to prove that these things are true. Alright, so for one of this identity, this one's a little tricky to start with. Remember, you have to kind of convert. Some people say that you're only allowed to really alter one side until it looks like the other side, and so that's what I'll do for this one. Although you just have to make sure that you don't perform any illegal algebra along the way. Any legal algebra is legitimate. What I mean by legal algebra is you can do the same thing to both sides of the equation. You have to be careful when you divide, though. You're not really supposed to be dividing very much, because at times cosine and sine can be equal to 0, and you're not allowed to divide by 0. And so we're going to try and avoid dividing. What I'll do is I'll just mess around with this. Cosine of 2x, I'll write it as cosine of x plus x, and I'll just leave this. I'm going to only mess around with this side in the beginning here. And now I know that I've got a cosine formula. It's the compound angle formula. I'll show it to you right there. Cosine, the sum of two angles, is equal to the cosine of one angle. I'm looking right here. This cosine of the sum of two angles is equal to the cosine of one angle times the cosine of the next plus sine of one times the sine of the next. Alright, and so in this case, the two angles that I have are x and x. So I'm going to rewrite this as the cosine of one angle times the cosine of the next angle minus the sine of one angle times the sine of the next angle. Just so happens that both of my angles are actually called x in this case. And so now this is still equal to 2 cosine squared x minus 1. So now I've got cosine squared minus cosine squared. Sorry, sine squared. So I've got cosine squared x minus sine squared x is equal to 2 cosine squared x minus 1. Alright. Now I'm going to look at this sine squared x. what I'm going to try and do here is mess around with this a little bit. Remember that cosine squared x plus sine squared x is equal to 1, right? And so what I can do is I can subtract a cosine over here, and I can say that actually sine squared x is equal to 1 minus cosine squared x. Sine squared x is equal to 1 minus cosine squared x. Okay, so now what I'm going to do is I'm going to get rid of this sine squared x. So I've got cosine squared x minus, I just told you that sine squared x is equal to 1 minus cosine, so I'm going to write 1 minus cosine squared x is equal to 2 cosine squared x minus 1. Now I'll distribute my negative sign, and I get cosine squared x plus 1. Sorry, it's actually a minus 1. Minus 1 plus cosine squared x is equal to 2 cosine squared x minus 1. And now cosine squared x plus cosine squared x is actually 2 cosine squared x minus 1 is equal to 2 cosine squared x minus 1. And so basically what we've done is we've shown that cosine 2x is actually equal to this by changing cosine 2x with legitimate legal algebra and formulas that are in existence, and shown that this is equal to that. Okay? That's one of the identities. Let me do another. Here's another one that I have written down. 1 minus sine squared x over cosine x equals sine 2x over 2 sine x. Now, here I notice that I've got a sine 2x, and if again I look at my compound angle formulas right there, sine of the sum of two angles, I can rewrite it as this here. So I might go ahead and do that. I'm actually not sure how I'm going to solve this in the beginning, but let's go through a couple of different ways here. Actually, here 1 minus sine squared x, I can rewrite that as cosine squared x yeah, I think this is going to work out all right. I'm going to change this side. So I'm going to write 1 minus sine squared x over cosine x is equal to, and I am going to change this sine 2x into sine x cosine x plus cosine x sine x into, and then I've got 2 sine x here. 1 minus sine squared x over cosine x. Sine x cosine x plus cosine x sine x is actually just 2 sine x cosine x over 2 sine x. Now this 2 and this 2 and this sine will cancel, and I've got 1 minus sine squared x over cosine x. Okay. And then so then I'm left with just a cosine x here. Cosine x over 1, I'll put. So now you might be thinking to yourself, oh shoot, I'm stuck here. But what I'm actually going to do is I'm going to multiply this side by cosine x over cosine x. Remember how I said you have to be careful with dividing things. I wouldn't normally I wouldn't be allowed to divide this, but the equation started out with a cosine in the denominator. So if the equation starts out with a cosine in the denominator, you can always have a cosine in the denominator throughout the rest of the question. And so it's 1 minus sine squared x over cosine x is equal to cosine squared x over cosine x. Alright, and now I'm going to change my cosine squared x for, remember my Pythagorean identity here, cosine squared x is also equal to 1 minus sine x, sine squared x that is. And so I'll change this to 1 minus sine squared x over cosine x and 1 minus sine squared x over cosine x. Alright, so again I only altered one side of the equation, and I kept altering it until it became what I wanted it to be. I suggest doing it that way. If you limit yourself to only altering one side of the equation, I believe you tend to make less errors, and it just turns out, it just sort of works. So there's a few things that we're allowed to do. We're allowed to multiply by cosine choice. Allowed to multiply by cosine over cosine. Remember, if you just multiply by something, you have to multiply by it over itself, so you're actually just multiplying by 1. You're allowed to cancel things. You're allowed to take sine 2x and write it as this using a compound angle formula. Then these are like terms, so they can be rewritten, which allowed us to cancel a bunch of stuff, leaving us with a single cosine. But I noticed that we needed double cosines so that I could get, see, I had to have some prevision here. So I had to know that this cosine squared x was going to soon turn into the sine 1 minus sine squared x that I needed. And so that's kind of the idea. So the best way for you to do these is to sit and actually just work through a bunch of them best you can. Make some errors until you finally see it. Then once you get one correct, go back and look at what was successful and what wasn't. I think a lot of people, what they do is they get one correct and they go, oh God, I finally got it. And then they move on to another one and sort of forget what made that question a success. So practice them and be intelligent about your practice. Well, there you go. We'll do definitely a lot more of these in class.